Let us now come to the second case study on the application of network analysis techniques to resource usage in online courses. We have indeed two examples here that we look at. One is a master course, one of my master courses on modeling and analyzing teaching and learning environments, which is what you could call a small private online course, or SPOC, according to Ed Fox. Or the second example then is a inter-university course with a larger number of users that is kind of MOOC style. Here you see some references to publications from this work. What is the situation that we have here in these typical online courses supported by learning platforms? In our case, the platform is Moodle. So we have in the log data, we have timestamps, we have actors, we have actions, and we have the resources that these actions apply to. And from such log files, we can generate bipartite networks that have two types of entities, namely the resources, the artifacts, and the students. So we have learner artifact networks. And we don't know exactly about the interrelation of the students. I mean, for specific resources, for instance, wiki tools, if students have accessed the wiki at the very similar or overlapping times, then you can say there may have been an interaction. But in general, we don't know about direct interactions between the students, but we just know about the interactions with the resources. These bipartite graphs are well known in the social network analysis methodology. Some of you may know the Wassermann-Faust book on social network analysis. This is a classical example from the book. It's the so-called Southern Women example. We have actors, women, who gather in events, maybe tea parties or so, and you have the coloring. Each color depicts a grouping of actors together with events that is more closely, more densely connected than the rest of the network overall. So we have the blue group, we have the orange group, and we have a group of black nodes. This is indeed the overlap of two. So these actors and events would belong to both groups. And we have the white nodes. They are not sufficiently connected to be considered part of any such cohesive subgroups. So how did we detect, or how can we detect such structures? First, in the simple case of a unipartite graph, an actor-actor network, for instance, we can apply the standard method that is called clique percolation. A clique is a completely connected subgraph. For instance, a clique of order 4 that you see here would be this square structure with the diagonals, so 6 links between 4 nodes. Now, what is the percolation process? You would try to delete one of these nodes from the clique, from the subgraph, and add another node. And if you can still form a new clique by doing so, you would propagate or percolate the clique. And you can thus exhaust the neighborhood around an initial clique, and you would consider this neighborhood that you can exhaust in this percolation process as a cohesive subgroup. This indeed can be generalized to bipartite graphs because we also have a notion of completeness. For instance, here we have, look at the green rectangle here, we have nodes 1 and 2, A and B, and the maximum number of connections that they can have in a bipartite graph, so no connections between the squares, no connections between the circles, is 4. And you see, if we shift now this, we delete the nodes 1 and A, and we add the nodes 3 and C, we get a new complete subgraph. So this percolation process is also possible in bipartite graphs. This is the method that we used, and we have indeed implemented this method also on our workbench. Here you see, again, this is an upload of a network. It's a first format transformation to transform it into our internal format. And then we have two sub-workflows, two threads. In the first thread, we first, as we say, fold the bipartite network into a unipartite network. What does that mean? If we have two users that have accessed the same resource in the given time interval, we would say they are related to each other. And so this gives us an actor-actor network to which we can apply the standard clique percolation method, as you see here. And then you can visualize the graph. Here, this thread is a thread in which we apply the biclique analysis directly to the original bipartite graph, so no folding before. From the literature, we would expect that the left-hand version is much more structure preserving, where this, the right-hand thing, has information loss and would probably generate less structure. And this is exactly what we see. This is the first fold and then analyze for the clique. With a clique percolation, we see it's just one clique with one outlier that is not sufficiently connected to the rest of the group. Not very interesting indeed. And here we see the result of the analysis on our data for one example time window. The different colors, the differently colored clouds, stand for groups of resources and users that are more densely connected in this time window. The black ones, again, are in overlaps. And here there is one at the bottom that shows a group of 3 students that have been particularly looking at certain videos. Interestingly, this was not based on an assignment. The other groups could be explained by assignments that these students had to work on, but this was just an emerging phenomenon that was not induced from the instructors. So, if we have such analyses, we can look at this in a dynamic timeline. In the timeline, we abstract more and we just look at groups of students and groups of resources that are connected to each other. Here on the top, we have one timeline. The orange circles stand for groups of students. And this group of students preserves a certain identity over the whole time, over the whole lecture period. And you see that this group of students connects to different resources in the different time intervals. Here we see that a certain resource cluster of resources is accessed over 2 time periods. Same here. And we can also see that, for instance, here this orange group accesses this resource cluster, whereas the same resource cluster is accessed by a different group in the next timeline. So this is the timeline analysis. We see a lot of variation towards the end. This is the exam phase. You see it's more diversified, more diverse when we come to the end of the course. This orange group is a group that we would call the mainstreaming group. So this group shows a certain continuous behavior with interest in the same resources at some given point in time, but of course changing resources over time according to what is kind of prescribed in the course. So we applied this analysis to our inter-university MOOC. And this was a MOOC on psychological foundations of computer-mediated communication, the CMC MOOC, as we say. The target group was students in what we call optional studies. These are studies not in your specific subject area, but kind of interdisciplinary studies. And we had the 2 universities, our University of Duisberg-Essen and the Ruhr University of Bochum. By the way, there we were collaborating with Nicole Rummel. Some of you may know her. It was a very heterogeneous group of students. It was a complete online course, so only online activities. And the students usually did not know each other, so we could really assume anonymous learners, like in a MOOC. Here in this variant, in this version, we had 162 students enrolled originally and 69 participating in the exam. This course was conducted on a MOOC platform, and this is how it looked like. So this is how the course is presented. And there were weekly videos. This is my colleague Nicole Kramer, social psychology in our university. And this was one of her standard lectures that we just kind of MOOCified for this purpose. Now, this course has the typical resources that you would expect. It has the videos, it has documents, reading materials, it has the quizzes for self-testing, it has forums, and we also introduced a wiki that came a bit later in the course, and it was student-generated material that was supposedly used also for exam preparation. So we have applied several evaluation techniques to the material that was generated in this course. First, just descriptive accounts of resource usage based on the log files, just participation meters and etc. This was done by our psychology colleagues. We have measured satisfaction with the resources and also motivation. We have looked at success predictors, and this was more our part here, was based on the network analysis techniques that you have seen before, where we have particularly been looking at the resource access patterns based on the bi-click analysis. And we have introduced a new construct that we call the mainstreaming coefficient, which we use for mainstreaming analysis. This is from the descriptive part, the participation over time. Here you see the resource usage in terms of resource types. What we were particularly interested in was, for instance, are instructor-provided, instructor-generated materials more frequently used than others? How about the wiki in the exam phase? Here you see that in the exam phase, the wiki, student-generated, learner-generated material, was quite widely used. And for the success predictors, we can say that based on a linear regression analysis, that indeed the quiz grades and the views of wiki articles, also the edits of wiki articles, were significant predictors for success, whereas just the course views was not. Now we come to this bi-click analysis in the same way that we have seen on the data of my master course. And here we have defined this mainstreaming coefficient in the following way. We say the mainstreaming coefficient is based on the quotient of, say, the number of different groups that a student belongs to, divided by the number of clusters that this student appears in. So the number of groups may be, or the groups may be constant over time. We have seen the mainstreaming group, and this group may associate to different resource clusters. So if we have a variety of interest that in the sense of different perspective taking, we would indeed expect the student also to appear in different groups and not only relating to different clusters. So if we look at this quotient, different number of groups, divided by number of clusters. For instance, student 26 appears in one group that is associated to 6 clusters, which stands for high mainstreaming. By taking the negative and then the exponential function, we get normalized values of this type. Here, for instance, we have student 2. This student uses or is associated to 5 clusters, so very similar to student 26, but appears in 4 different groups. So this student shows much less of a mainstreaming behavior than student number 26. Now, taking this mainstreaming construct, you could say, oh, that's a quite artificial construct, but we could see that mainstreaming correlates positively with extrinsic motivation, which was measured by the psychologists using corresponding instruments. And what does that mean? Mainstreaming correlates with extrinsic motivation. So people who just participate in the course to get their credits are more likely to just stay in the mainstream, not to diversify. We saw, on the other hand, for instance, that the contributors to the wiki, they had a relatively, or on average, lower mainstreaming coefficient. Yeah, these are just some findings about the wiki editing, but this finding is specifically related to the mainstreaming property. In summary, we can say that most of the students access the mandatory materials, they follow the sequence of the course, and there is a higher number of students that really appears in this mainstreaming group. We found more diverse behavior, more diverse interrelations between student groups and resource clusters in the exam preparation phase. We saw in general a high satisfaction with teacher-generated content, but we also saw productive use and appreciation of peer-generated content. There were also reports on, say, more effective parameters that were say, measured with other instruments that I have not been talking about here. And we have seen the predictors. We have seen that quiz grades and wiki access are positive predictors for the final grade. So this was the second example, and what you should have seen here is, again, we can use network analysis techniques with quite simple basic data. We just have these resource access data, but we can maintain a lot of structure if we keep the bipartite nature of these graphs, do the structural analysis there, and then we can do the dynamic, say, timeline analysis of these data.